recorder. We're going to go ahead and get 11 out of the way. And this is my plan. I want everybody to listen to this and write this down so I don't have to say this again. We are going to cover 11.1 and 11.2, and we are done. But I do realize that y'all might have questions. There are some in chapter 12. I've already received some. And there's going to be some in chapter 11. And I'm going to give y'all 1 week maybe to send me questions in chapter 3. If I don't receive any questions in the next week on unit 4, that's the geometry section, and we're going to go ahead and call it a semester, and y'all can work at home and don't have to come to class or anything like that. But that's not this week, that's next week. So we might be able to finish a couple of weeks early if everybody cooperates and tries to get their homework done on the chapter, 7 and 8 or 8 and 9? What is it?
Chapter
7 and 8.
8 and 12.
No, I've covered 11. I'm covering 11 today. I've covered Unit 3. Unit 4, I need y'all to go ahead and get into that homework so y'all can start sending some, because after I finish today, I'm going over the test for Unit 3 and homework questions Wednesday. Okay? So Unit 3, after Wednesday, is going to be up and running as far as the test goes. So all that's left is that last unit. Now, I don't mind teaching till the last day of class. Do y'all understand that? I don't mind teaching. I'm here. I don't care. So it's up to y'all if y'all want to spend the next 2 weeks or the next 3 weeks. That's up to y'all. So I want y'all to, try to get into the Unit 3 homework as much as you can and start sending questions. Wednesday, I will go over homework questions and we'll do the test on Unit 3. I will also, in the next week or two, talk about the final exam, how many questions will be on it, when you can take it, but I already told you the week of finals is the, December the 4th through the 10th or something like that. You have the whole week, okay? You'll have until the last day of class to do all your Unit 3 homework, Unit 4 homework, and Unit 4 test. And that's December 3rd. So you should have December 3rd, end of Unit 4 in your calendar, and then December 4th through the 10th, final exam. And then when you finish those 2 things, you go to your grade book, hit my grade, and that's your grade. Do not email, text, or call me asking what your grade is. If you can't read a score and tell me what your grade is, then I don't know what else. You should fail this class, okay? Because all you got to do is hit overall grade. All right, and I'll give y'all, probably after we finish the Unit 3 test, I'll talk to you about that the next class or somewhere in there that next week. We'll go over all of that stuff because I do it for all my other classes. So I'll be doing it for the 110 that I teach this morning, so I'll remember to do it for y'all, and I cover it in all my classes. All right, so that'll tell you. I just want to tell you that because some of y'all are going to be asking, y'all going to start to go in stupid mode. That's when y'all go in stupid mode. The last 2 weeks of class, that's when y'all start going into, it's somewhere between stupid mode and Hammy the squirrel. And y'all start bouncing around, y'all start hyperventilating, and you don't have to do that in my class. You have until December 3rd to get the last test done. You have December 4th through December 10th to get the final exam done. When you're done with that, you're done with my class. All right, so here we go. Current slide. This is probability. Now, what is probability? I'm going to give you a Hubertism definition. And make sure you write Hubertism. Oh, shoot. Hold on a second, guys. Thought I changed this. Okay, now, y'all got to, here we go, sending it to y'all, just to make sure y'all got it. That's not right. hold on a second. Present desktop. I want to make sure y'all getting it. There. Okay. And it should now do it the way it needs to do it. There we go. Okay. It was covering y'all's faces up, and I don't want to cover y'all's faces up easily. Okay. All right. So here we go. What is probability? Well, nobody can tell the future. Why do I say that? Well, I had a friend one time, not a friend anymore, told me that she could tell the future from my dreams. That I needed to write down my dreams, and she could tell the future by what color my dreams were. Like if I dreamed of a horse, it was what color is the horse? Because the horse of a different color means something. And if you saw your parents or your dead brother or sister, or if you saw that, that means this. Of course, like I said, she's not my friend anymore because I think she's ready for the loony bin. But the whole point is, why would somebody like me say that she's crazy? Well, one, nobody can tell the future. Does anybody want to debate me on that? Because if you tell me that somebody can tell the future, I just got one question I want to ask them. Anybody want to know what that is? Anybody want to take a guess what my question is? Nobody? Nobody knows what my question is? What is, if somebody could tell the future, what would Hubert ask that person? What is lottery numbers for the lottery, for the next lottery? That's what I would ask them. And y'all would ask the same thing, would you not?
Yeah.
Oh, I'm gonna ask when I'm gonna die. Yeah, that's a very good question to ask. Because when you die, you ain't gonna know it anyway. The whole point is, if somebody walked up to me and said, I can tell you your future, I'd be like, okay, give me the 5 lottery numbers for the Friday night lottery. Oh, that's not the way I do things. Oh, shut up. Get out of my way. You're a fraud. Nobody can tell the future. Well, Hubert, how do people guess things? That's right. What did I say? I said guess. All right? Nobody can tell the future. But there's a road that goes to Pendleton. And that road is called Wild Hog Road. Now, I don't know if you people can easily know about a road like this, but Wild Hog Road goes from the west side of Anderson. Here's the west side of Anderson. Double Bridges is right here. They're going across Lake Hartwell. This is 24. And this is Garrett's. And this is Wild Hog Road. It goes from the west side of Anderson to Pendleton. And the Waffle House in Pendleton is over here on the left. All right, the main thing, the reason I'm showing you this is if you live on the west side of Anderson, if you live anywhere on the west side of Anderson, and you're going to go to Pendleton, you're going to use Wild Hog Road, okay? And you get on that road, let's say you got an 8 o'clock class, it takes 16 minutes to travel Wild Hog Road. How did I know that? I taught at Pendleton for 15 years. I rode that road, if you want to do the math, 15 times 365 times 2. Okay, pretty much. I traveled that road pretty much every day of the year. Okay, except for a couple of holidays and summer vacation. Okay, every day I traveled that road. So I know, bless you, 16 minutes. So if you wanted to get to a 8 o'clock class, you get on that road at 15 till, you might make it. Oh, hell to the no. Why? Because if you're in a hurry and you get on Wild Hog Road, I can guarantee you, you're going to get behind the Little Blue-Haired Ladies Club. Anybody know who the Blue-Haired Ladies Club is?
Old people.
And they go how fast?
10 miles an hour.
34 miles an hour. 34 miles an hour. And that's going downhill with no brakes. Okay? And you're going to get right behind that person. And you're going to get up here. Pendleton High School is right here. Pendleton High School is about a quarter of a mile to Clemson Boulevard, right there in Pendleton. Okay? And by the time you get here, you get about 500 feet to that red light. You're going to say to yourself, that lady's going to turn left. And just as soon as she says it, what happens? Turns her left blinker on. Did I just tell the future? No. What did I do? I guessed at an event using three things: experience, mathematics or deduction, and logic. Now with this, I didn't do much math on this one because sometimes you use math, you use data. You know, surveys, percentages, that thing. I use predominantly experience and logic. Most of you would say, well, Hubert, I understand the experience because you just said you traveled that road 16. How many of you have a road that you travel easily, like Wild Hog Road? A lot of people say, well, why don't you pass, Hubert? You can't. Because there's so much traffic on that road that it's double yellowed line. 88% of that road is double yellow line. And if you try to pass, you might have a head-on collision. Okay? It's not straight like I showed you. So why would the logic come in? Well, if you live on west side of Anderson, you know the logic. If you live on the west side of Anderson, there's only two ways to get to Sandy Springs and Pendleton. Sandy Springs is down here. It's where the Michelin plant is. Sandy Springs is this way, and Pendleton is the left. Now, how did I know the little old lady wasn't going to Sandy Springs? Because there are 3 to 4 different roads that you turn off of on Wild Hog Road to go to Sandy Springs. So logic would dictate that if the lady didn't turn right on those 4 roads, where is she heading? She's heading to Pendleton. So that's why I could predict that she was going to turn left. The experience comes from riding that road 16 years or 15 years. So with the experience and logic, I was able to predict an event happening. That is what probability is. Probability is using experience, mathematics, logic, observation to assign a number to a guess. Assign a number to a what? To a guess. And that number is going to be between 0 and 1. It's going to be between 0 and 1, which means a decimal. Now, if you take my Math 120 or 103, we are going into the second unit today. 11.1 and 11.2 is about half of the second unit of Math 120 and 103. So you've already been through the first unit with 11 or 12. That's the first unit. Second unit is chapter 11 in this book. Okay, it's not the same book, but same material. So make sure you write those few things down. Assigning a number to a guess of an event using experience, mathematics, logic, and observation. And that's what probability is. There it is. Okay, it's used in a lot of stuff, especially traveling down Wild Hog Road. Now, what is games of chance? Well, y'all know what games of chance is. That's a 25-cent politically correct word for what? Gambling. All right? Gambling is so negative. Okay, so we have to change it. There's two types of events that happen in probability. An experiment and an observation. I'm going to go ahead and write down observation because I'm not familiar with these slides, so I don't know if they're going to go over observation. Somebody tell me the difference between an observation and an experiment.
Experiment or
What do you do with an observation?
You just watch it happen.
Observe. What is the key word in that experiment definition that makes it different from an observation? There's one word. Makes up a lot of things that you have to deal with in a relationship as well as a job. What is the word that changes the definition between an observation and an experiment?
Control.
There you go. There is a very powerful word. Some of you may have had run-ins with control. Some of you people may have a controlling significant other, whether it's a boyfriend, girlfriend, man, wife, or whatever. Some of you may have a controlling boss. Control can lead to people acting crazy. Any of y'all ever been in a relationship where the controller just went crazy on you? I mean, you might have. It's all about control, as the old saying goes. What's the difference, all right? An observation would be like a mouse in a maze. What does the mouse do in a maze? Runs around until he finds the what? Finds the exit. Okay? Or finds the piece of cheese. No, that would be an experiment. But if you add a piece of cheese to the experiment, you have just inserted what? Control. Why? Because is that mouse priority going to be getting out or getting to the cheese? Because he smells the cheese. It takes priority. You have controlled that mouse. When you control something, that's the difference between, this is a test question. It is a standardized test question. So make sure you know the difference between an observation and an experiment. Let's say that I go outside and I put an electric fence up, one of them invisible electric fences for your dog, and I put it up and I don't put the collar on him. Then that is an observation. But when I put the collar on him, it turns into an experiment because he cannot go outside of that fence. He's controlled. Control is the main word that differentiates an observation from an experiment. Is that important? Yes, that is a test question, and you should know that. Okay? Possible results. Results, outcomes. Results, outcomes. Another word for, when it says results, it's the same thing as outcomes. An event is a collection of outcomes. Okay? How many people voted this or that? Those are outcomes. What about the event? What about the whole precinct? That would be the event. because everybody in the precinct voted this way or that way. Everybody see? There's a difference between an event and an outcome. An outcome is an individual. An event is a what? Collection. Not as big a question as the first two, but you need to know what outcomes is. Outcomes means results. That could be a question. Event, that's not really a standardized test question, but you need to write it down. Just remember, a collection of what? Outcomes. Empirical probability. We've already talked about empirical. I've already showed you empirical probability. Well, I've showed you the percentages. Write these two down. You don't have to write it word for word. Empirical probability is what I call the theoretical probability. I'm sorry, this is theoretical. This is called the physical probability. This is what I call the physical probability. And the reason I call it that is so it will stick in your minds. The theoretical probability is what I call the Mayberry probability. And I'll give you an example. Well, first of all, why would I call the theoretical probability the Mayberry probability? Where is Mayberry? Somebody tell me what Mayberry is. Mayberry, North Carolina.
That's where Andy Griffith is set.
Thank you. The TV show, Andy Griffith Show. Why do so many people, and I really don't care if you like it or not, that's not what I'm asking, but there are a big following of people like me that have trivia games, trivia cards, trading cards, memorabilia from the Andy Griffith Show. Why do a lot of people, and it was made before I was born, why do people have a fascination with the Andy Griffith Show? Does anybody want to take a guess at it?
It was a calm, peaceful, great town.
It was a modern day utopia. That's right. Perfect. Perfect answer. Utopia is the perfect what? Place. Now, in theoretical probability, that means the perfect scenario. Let me ask you one quick question, and that will explain theoretical probability. What is the probability of pulling a king out of a deck of cards?
4 out of 52 cards.
The probability, somebody already got it. Show me your deck of cards.
I got 2 in my car.
No, where are they? You just gave me the probability of a king is 4 out of 52. Where's your deck of cards?
In my car.
Yeah, but you didn't do it there on the table. How did you know it was 4 of 52?
Because I know that there's 52 cards in a pickup and there's 4 of each suit.
Exactly. So your answer is based off of 100% what? Mathematics.
Fact.
It's based off of what you know about the deck of cards. And what is it called? Theoretical. In other words, that is the perfect Mayberry probability. But it's not the what? It's not the actual probability. Now in Math 120 and 103, I actually give people, the classes that can handle it, y'all would be a class that could handle it, but I can't throw the deck of cards through the screen to the Easley campus, so I don't do it in this class.
I got 2 decks of cards.
I appreciate it, but we're not going. We may do that Wednesday. Bring them Wednesday, and I may bring the Anderson campus some Wednesday, and we'll do it.
Okay.
If I asked y'all to take a deck of cards, shuffle it up after each time you pick a card, and you write down 10 draws. 10 times you draw a card. Put the card back, shuffle it, have somebody pick a card, write it down. Put it back, shuffle, pick a card. It will not come up to this number. 4 out of 52 is 0.25. Okay? So that's the probability of, or 1/4. This probability, if the actual probability, if you had a deck of cards and you pulled 10 cards and shuffled them each time and put them back, it would not equal 0.25. Why? And we're going to get into that with the law of large numbers. That should be, I hope, the next slide. Let's see if it is. Hold on. Just give me a second. I want to get to the law of large numbers. There we go. Write down the law of large numbers. The law of large numbers states that the probability applied in practice to a large number of trials, not to a single trial, it is the relative frequency over the long run that is accurately predictable, not in what. You don't even need to write that down because that's garbage. Okay? Law of large numbers. Actually, it's a good way, if I could work this dadgum board, I need training. It's a good way what's that stand for in the real world? What does it cover for? What does it stand for? I just told you.
Check your ass.
Cover your back end. I can't say donkey in real world because somebody might be offended. We live in the snowflake buttercup world. So cover your ass. What does that mean? When you do a job, what do you usually do in the real world? When you do a job, you write what? You write down what you did, you write down the numbers, and you follow it up with paper what? Paperwork.
Paper trail.
Because somebody may say, well, you didn't do it correctly. All right? The law of large numbers is kind of a way to cover your rear end. Let me give you an example. A while back, and they used this in a book article, in one of the books we used to use, there was a couple of MIT students, and they wanted to find out how many flips, write this down, and this will make it stick. How many flips of a coin would it take to get the physical probability equal to the Mayberry probability? Because somebody tell me what the probability of a coin to hit tails is. 0.5. Because how many sides of a coin is there? And does the coin ever lay on its edge? Or does it always lay on one side? It always lays on one side. So what's the chance of it being tails? 1/2. They wanted to find out how many flips it would take, flips like this, to get a 0.5 probability. So what they did is they took a roll of quarters, They took a roll of quarters. How many quarters is that? 40? And they measured each one. Now, when they say they measured, I'm not talking about Billy Bob Redneck measured. I'm talking about they measured the width. They measured the height. They infrared scanned it. They measured the weight. They measured and did a lot of the balancing. They put all of these 5 or 6 different factors, and they built a virtual quarter. What do you mean a virtual quarter? They actually programmed, they took all the averages of all those measurements, and they put that quarter in the computer based on that one roll of quarters. And they wrote a program flipping that quarter. Does anybody have an idea how many flips it took? They programmed it into a computer program. Somebody want to tell me how many flips it took for the probability to hit 0.5? It actually hit .49999995. Anybody want to tell me how many flips?
4.
4? How many flips? Anybody want to guess? 1? It took 100,000 flips for the computer to get a probability of 0.5. What the heck do you mean, Hubert? Well, let's say I gave you a deck of cards and you shuffled. You picked. You say, I want to know what's the probability of a king. Well, we've already established that the Mayberry probability of picking a king is 0.25. Everybody agree with that? So you do 10 shuffles, and you get a 2, you get a 4, you get a 7, you get a 2, you get an ace, you get a queen, you get a king, you get a 2, and a 8. How many is that? 1, 2, 3, 5, 6, 7, 8, 9, and then you get another jack. Okay, there's 10 shuffles and 10 picks. What is the probability that you got a king? 1 out of what?
10.
1 out of 10, which is point what? 0.1. So the 0.1 doesn't equal the 0.25. The large number rule is basically a rule of large numbers to get these two to what? Get as close as they can to each other. It's a way or a method in research to get the physical probability as close as possible to the theoretical probability. Everybody with me? The theoretical probability does not change. Somebody tell me the probability of rolling a 6 on a cubed die. 1 out of what? Where's your die? How'd you know that? You know knowledge. Okay? Will 1 out of 6 ever change? No. It's based on mathematics. It's based on that cube. It's based on having 6 sides. Everybody with me? So is there any way that probability on that die is going to change? No. Does that mean that if you roll that die 10 times, you're going to hit a probability of 0.16? No. And that's why we have gambling. Because the Mayberry probability is always going to stay here. And who does that? That's the house. And who does the physical probability? You as a what? A gambler. The house doesn't change. And you're betting on if you can hit the what? The house. And that's why we have the law of large numbers. So, what does this, let me tell you what this means. What time is it? We only have 10-minute class.
We have 10 minutes left.
I got 10 minutes? Okay, let me go here and go to the whiteboard. And I'm going to show you something. You ever have a moment when you have something in your brain and it goes out of your brain and you're trying to grab onto it?
All the time.
Okay, well, I just lost it. So I done forgot where I was going with it. Oh well, I'll try to think of it between now and Monday. Let's go ahead and call it a day. You need to get 12.1 to 12.4 done, and we'll start. You can go ahead and try to start, but I haven't finished 11.1 yet, so we'll finish on that come Wednesday, okay? Or Friday, because Wednesday we'll probably go over 12.1 questions or 12 questions, yeah, or Friday, one of the two. Y'all have a good day. And thank a veteran. Give me money. All right, see y'all later.